Hey there, today we'll be solving today's contest question, that is 2304, maximum path cost in a grid. And the question statement given is, you are given a zero indexed m cross n integer matrix grid consisting of distinct integers from 0 to m cross n minus 1. You can move in this matrix from a cell to any other cell in the next row. That is, if you are in a cell x comma y such that x is less than m minus 1, you can move to any of the cells x plus 1 comma 0 till x plus 1 comma n minus 1. And note, we cannot move from the last row, and each possible move, by the way, actually this line right here actually confused me for some time. This line right here, so this line actually was confusing for me at least. So each possible move has a cost given by a zero index 2D array move cost of size m cross n, where move cost ij is the cost of moving from a cell with a value I to the cell in the column j of next row. So actually the whole idea behind this is, you'll just have to read this line actually very carefully in order to understand this. But do not worry, I'll be explaining this line. Okay, so the cost of moving from cell in the last row of grid can be ignored, and we just have to find the minimum cost. Okay, so how are we gonna do it? Obviously, we're gonna use DP. So let's jump onto it on how we're gonna do it. First, let's understand how this cost array is being uh, manipulated. Okay, or how we are going to use it. So actually, if you see right here 5 3, and so this is the matrix right here that is already given. Fine, not a problem. But if we just come here to the move cost, that is this 9 comma 8, how is this cost 9 comma 8 coming out to be? So actually what they are saying is, whatever the value that is there, that is, I'll just draw the grid right here once more for clarity. So I'll draw just a smaller one, okay, for this sake of just understanding. So I'm at a position 0 comma 0. Fine. So at 0 comma 0, what is the value that is present here? So the value present here is 5. So what we're gonna do is, if we want a cost from here to, let's say, this guy right here, we want to go to 0. So what we're gonna do, we are gonna go to the move cost array that is provided here. We're gonna say this value right here, that is grid of ij, which is 5. Okay, which is 5. And where do I want to move? I want to move to this position, that is to 0, right? This is where I want to move. And where is this? This is just one column ahead. Fine. So I'll be making a jump of what? So I will be going to I plus 1th coordinate, that is from 0 0 to this row and this column, right? So what will be my coordinate jump? This will also be j plus 1, sorry. So I is representing the row and j is representing the column. So basically I plus 1 and j plus 1. So what will be the column? That will be 1. Okay, so whatever we got a value 5 comma 1, right? So just replace this with the move cost array. Okay, MC means a move cost array. So in the move cost array, you just find this value and you'll get the cost of going from here to here, and which is 5 comma 1, right? So which is here. So 0 1 2 3 4 and 5 and 1. So which you actually see, that is the cost right here, that is 3, right? So you must have now understood this part, that on how to decipher this thing that is written here. And if you had known it previously, so just bear with me, I'll just explain the procedure on how to do this code also. Okay, so right now this is very clear, and by looking at the question, it is pretty obvious that we just need to find the path. That is, let's say if you are starting from here, if you go like this, is it giving you the minimum cost? Or you could do something like, is this giving you the minimum cost? And you just have to try all the possibilities, right? So that is the question, and for that we just reach to the conclusion that we are going to use DP. So now let's understand on how we're going to do it. So in order to do this, you should actually know the question, that is minimum falling sum, I guess that is it. I don't actually remember the question name, but that is pretty similar to this type of question that is on DP on grids. But anyhow, let's understand how to do it. So the question states that I will be taking the first only. Okay, the first, let's just do it here only. That is right here. So the question states that you can start from any of the row, not any of the row, sorry, any of the column from the first row. That is, you can, that means if this is our matrix, you can start either from here or you can start either from here. So after that, what you can do is you can go to any column, mind you. Okay, and what do I mean by that? Let's say if you are starting from this column right here, the 0th row and the 0th column, that means after that you can make a move to this position or this position. Let's say if you had some any other value also, let's say this is a 3 cross 3 matrix, so you could move, sorry, here also. Okay, so that is what the question is stating. So at a particular index and at a particular column index, you can go to the next row and move to any of the ijth position grid. Fine. So likewise, if you are right here, you can obviously go here and here also. Fine. So this is the basic approach. Okay, so after this, let's get on to how to do it and what are the states. Okay, so here obviously the states are ing, and what is ing representing? Ing is representing my row and column. Fine. So dp of ij will be representing my row and column. So what can you do? So let's see. If I just take a smaller example, let's say like this. Okay, so let's say you start from right here at this position, that is 5. So this is where you're starting from. So if this is where you're starting from, I could say I can move from 0 0, that is the position of 5, and move from where to where, that is, sorry, this, to 1 comma 0, that is this position, and you could move to this position, that is diagonally, right? So this could be 1 comma 1. So these are the two things that you can do right now if it is a 2 cross 2 matrix. And likewise, you will do the same thing for this 3. If you start from 3, what are the positions that you go on to? So if you start from 0 comma 1, what are the positions you can go on to? You can go here or you can go here. So either you can go 1 comma 0 again, or you can go 1 comma 1. Okay, so these are the possible states. So basically dp of ij represents the row and column, and you can either move anywhere to the next row, anywhere to the next column. Fine. So to the just next row and anywhere in the column, that is it, where you are moving. Fine. So now let's get to the code part and understand it, how we're going to do it. So moving on to the code, as I said right here, while it's explaining, I'll just draw another matrix right here, that is 5 3 1, and let's say 2 4 and something like a 5. And I have not written the cost or something like that. What you're gonna do is, as I said, you could start from here or here or here, right? So that is what I am doing right here in this part. So I can either start from any of the columns, okay, of the first row. So I've just iterated from 0 till the last column, and I've said you can go from the 0 comma ith position. Okay, that is either from here or from here or from here. So these are the things. After that, I just called a function, helper function right here. And what this is going to do is you're just getting all the minimum cost. And how we are getting the minimum cost? See, what is this loop doing right here? So this base case is pretty simple. If we just reach the last row, what are we returning? We are returning whatever the value of grid of ij is. That is, if you are reaching here, that is at 2, if you are reaching at this position, you just return whatever the value was there. And why not the cost? Since it was mentioned in the question somewhere here, I think that the last that is right here, cost of the last row can be ignored. Okay, so you don't need to calculate the cost of last row, you just only need to return whatever the value of the last row is. Fine. So if you reach the last row, you just return grid of ij. Okay, and this is the memorization part, that is pretty obvious. So what am I doing in this for loop? So I'm saying, if I'm at a position, let's say, if I'm at a position 0 comma 0 for now, let's say, okay, I'm at this 5 right now. What are my options? I can go here, here, or here, right? So this is what that for loop is doing. I'm saying iterate from 0 till the last column, okay, and from the ith row I can go to the next row, right? So I will say go from ith row to I plus 1th row, and what all columns do I have as my options. So the columns that I have my options as, let's say this is this loop is j is equals to 0 till the last column, so I have my options as I plus 1 to j. And what does this I plus 1 to j mean? That means you can start from here, that is right here, you can go here, or you can go here. When I is equals j is equals to 1, when j is equals to 2, you can go here, right? And this I plus 1 is constant because we are moving the row by 1, and this j is changing according to this for loop. Fine. So I hope you have understood this part, okay. And this dp of ij is just simply a memorization part, okay. And yeah, this is it for this explanation part, okay. And you just need to return the minimum for all the answers, and I've just taken a temporary variable here also. You could just simply put this function that is right here, that is this function. You can replace this with this also, okay. So as you like it, whatever you want, I just did it for simplicity. And yeah, this is it for this explanation. And if you did understand this, please do like and